All right, so today we're going to talk about volumes of prisms, and in a way it's kind of like a cube, but a prism isn't necessarily a cube, where a cube has all the same sides. So we're talking about something that might look like a box of different lengths. So if we think of like a rectangle that's kind of stacked on each other, that's what we're talking about with prisms. And there's a couple different kinds of prisms that we'll get into in examples here. In general, the volume of a prism is going to be base times height, right? So you take the volume of the base times the height, sorry, the area of the base times the height. For this specific prism here, we're going to go length times width times height. We're going to get into a different example in a minute where we're going to use the base times height and show you how to do that. So if we take this concept of base times height, if we can call whatever side we want base in this case. So if we go 8 by 10, that would be our base times our height, which is 2. And so this becomes our length times width times height translation. Okay. All right. And we end up with a volume of 160. All right, so now we have a question here. It says, does the volume change if we go by 10 by 2 and the height is 8? So if we were to turn it, does it change the volume? But one thing to ask is, did the shape actually change dimensions? It did not. So the area is going to be, sorry, the volume is going to be the exact same thing depending on what the orientation is. The dimensions actually don't change, so the volume doesn't change. All right, example 2. This prism is different. This is actually half of the type of prism we just dealt with. So the base in this problem is actually a triangle, so we would call this a triangular prism. So there's 2 ways to do this. If we do the area of the triangle, right, we can multiply that times the height, which in this case would be 40 millimeters. So although it's laying down in the picture, if we turn it up, this would become the base, this would become the height. Now the question is, how do we find the area of a triangle? Well, if this is 20, we don't know what this is right here. It doesn't tell us. So they do tell us this is 29. So what we're going to do, this would be 29 as well. So we're going to do some Pythagorean Theorem to find the missing side right here. All right, so we have x squared plus 20 squared is equal to 29. And so we go through Pythagorean Theorem and find that the side length is actually 21 units. Okay. So now we have 20 by 21. And now we can take our area, 20 by 21 times 40, right? And that would give us the volume of a regular prism, but how much of the prism do we want? Only half. And so I'm going to throw in the divide by 2 here. Another way to do it would be base times height divided by 2 times 40, which is another way of doing this calculation here. All right, in either case, you're going to get a volume of 8,400 units cubed. All right, the next one here, this is another triangular prism. Now the difference between these two, this is a right triangle, this is not a right triangle. Okay, this is in fact an equilateral triangle. And so to find the area of an equilateral triangle is going to be a little bit different than the area of a right triangle. So we're still going to do base times height. We could use some trig if we wanted to. Because it's equilateral, we know the angle, but that doesn't always work out in problems. So let's do the way that will work out all the time, is we need to find the height. We have the base, we just need to find the height. So the first thing we're going to do is Pythagorean Theorem. So if we were to draw the height down, what happens to this 4 is it gets cut in half. And then we have our hypotenuse. So our Pythagorean Theorem would be the height plus the base, half the base squared equals to the hypotenuse, or the diagonal side. And when we go through and do our math, we get a height of 3.5. So now we have our height and we have our base. So we have 4 times 3.5 divided by 2 times the height of the prism, not the height of the triangle. And so we get a base of 7, and then we multiply it by the height, which would give us a total volume of 63 units. So again, we found the area of the base, and then we multiplied it by the height. So this example, I did the area of the base, multiply it by the height. And again, how do we find the area of the base? We had to use Pythagorean Theorem to figure it out based on what we know about equilateral triangles. All right, here's the next example. Very similar. This is just a rectangular prism. So we're just going to multiply all 3 of these together, and we get 1,190. This one is pretty easy. I don't think many of you will struggle with this type of problem. All right, one last thing to talk about. This is called Cavalier's principle. And it says if you have separate figures, they can be different shapes. If they have the same height and they have the same cross-sectional area at every level, right? So if you take a slice out of each shape, right? And you do that, and all those slices are gonna be the same area on all those shapes, then these three shapes right here are going to have the same volume. So this becomes an easy way to compare volumes when needed in the future. And this is called Cavalier Arias principle.